Hello, and welcome to your Chemistry 1412 lecture over coordination compounds, shapes, and nomenclature. Coordination compounds are beautiful and also essential to life. Naturally occurring coordination compounds are vital to living organisms. Metal complexes play a variety of important roles in biological systems. Many enzymes, the naturally occurring catalysts that regulate biological processes, are metal complexes. Biologically important coordination compounds include chlorophyll, a magnesium porphyrin complex, and vitamin B12, a complex of cobalt with a macrocyclic ligand known as chorin. Coordination compounds contain D block elements. D block elements are all metals, so of course, most are good electrical and heat conductors, malleable, ductile, and lustrous. Most are also silver-white in color. D-block metals also have some unique properties. When they become cations, they lose their s electrons first, and then they lose one or more d electrons. The charge of the cation depends on the number of d electrons the metal loses. Because these metals can have many d electrons, the number of charged states are quite numerous. Vanadium, for example, usually has one of four charges: 2 plus, 3 plus, 4 plus, and 5 plus. Each charged state gives vanadium a different color. In fact, vibrant colors of the different charged states of d-block elements make them some of the most beautiful chemicals on which to do experiments. D-block elements are also unique in their lanthanide contraction. This contraction makes sense if you think about the same type of contraction which occurs in the s and p blocks. The addition of a proton and an electron within the same row of the periodic table leads to a higher effective nuclear charge. This increasing effective nuclear charge causes the atoms to become smaller along the row from left to right. Between elements lanthanum and hafnium is the first row of the F block. 14 protons and 14 electrons are being added. This addition increases the effective nuclear charge by a large amount between lanthanum and hafnium. This is why the 6th period and the 7th period are nearly identical in size, contrary to expectation. D-block elements form beautiful colored solutions in water. The different colors stem from the different energies of the d orbital electrons. We will look further into this phenomenon, called crystal field theory, in the next lecture. When d-block elements form a coordination complex with water, the water acts as a Lewis base. Oxygen is donating a pair of electrons to the bond, and the metal acts as a Lewis acid, accepting the electrons in the bond. These bonds are called coordinate covalent bonds. Just as in crystalline solids, coordination number in coordination compounds is the number of atoms bonded or touching the central atom. The number of ligands detached is easy to discern from the formula of the compound usually. An exception is when the metal has a polydentate ligand attached. We will speak more about that later in this lecture. Here you see one compound called hexacyanoferrate 2 with a coordination number of 6, and another called tetracarbonyl nickel with a coordination number of 4. This lecture's main focus is on learning the nomenclature of coordination compounds. The names can be very complex, but the method of naming them is very structured. The first thing one must do is memorize the names, formulas, and charges, or have a list of the ligands handily nearby. When naming complexes, you name the ligand first and then the metal atom or ion. In the example given, there are two kinds of ligands, nitrito and amine. If there is more than one of a ligand, then you must use Greek prefixes to specify how many of each there are. In our example, there are 5 amines and 1 nitrito. Therefore, the name will include pentaamine and nitrito. There's no prefix if it's single. The ligands go into the name in alphabetical order according to the ligand name, not the prefix. Amine comes before nitrito in the name. In the formula, the order of the ligands is according to their charge. Anionic ligands come before neutral ligands in the formula. From the charges on the ligands and the overall charge on the complex, you can determine the charge on the metal. Nitrito is -1, amine is neutral, the complex is +2. Therefore, the charge on the metal is X in +2 equals X minus 1, or 3 plus. X is equal to 3 plus. The charge on the metal comes from after the name of the metal in Roman numerals. Once the name of the complex is known, the name of the whole species is named according to ionic nomenclature rules. The example molecule is named pentaamine nitrito chromium 3 chloride. The complex in the previous example was a cationic complex. If the complex is anionic, add 8 to the end of the name and the metal. Examples are hexacyanoferrate 2 plus and tetracyanonickelate 2 plus. The name of the coordination compound, as distinct from a complex cation or anion, is built in the same way as a simple ionic compound, with the cation named before the anion. For example, the two complexes shown are ammonia amine trichloroplatinate 2 plus and tetraamine dihydroxychromium 3 plus bromide. Complexes have different three-dimensional shapes depending on their coordination number. All complexes with a coordination number of 6 are octahedral. Complexes with a coordination number of 4 can be either tetrahedral or square planar. Predicting the shape of coordination 4 complexes is difficult. If knowledge of shape is needed, it should be given on exams and homework. Some ligands have more than one atom which can donate an electron pair to make a bond. These are called polydentate ligands. Ethylene diamine is a common example of a bidentate ligand. It has 2 nitrogen atoms which can act as a Lewis base. The suffix dentate has a Latin root which means tooth. Ligands are said to bite onto the metal atom when forming the bond. They are sometimes called chelates. Chelates has a Greek root of claw. The shapes of complexes with polydentate ligands can be very complex. EDTA is a ligand with 6 atoms that can form a bond. EDTA is used to clean the body of lead cations. It is the antidote to lead poisoning. This has been your Chemistry 1412 lecture over coordination compounds, shapes, and nomenclature. Please go now and complete the homework assignments associated with this lecture. If you run into confusion, please ask for help. Help is always available.